Good morning, everyone. I think we should start. We waited now 3 minutes for other participants to join. Firstly, very good morning from Chile. Good afternoon to Europe. My name is Philip Bartsch. I'm the Deputy Managing Director of the AHK Chile, the German Chamber of Commerce and Industry here in Chile. On behalf of RWE Technology International and the German Chambers of Commerce of Chile, Peru, Colombia, Uruguay, Brazil, and Mexico, we warmly welcome you to today's webinar, Growing Green, Decarbonizing the Energy Sector. First, some administrative remarks. The webinar is equipped with a simultaneous translation feature. You can change the language on the setting down at the globe icon. For topic-related questions about the presentations, please use the Q&A function. General questions can be asked in this chat. All functions can be found at the bottom bar of the Zoom applications, and very important, after the webinar, you will be given a survey to evaluate this event. Let's start. The transition of the energy sector towards a goal of zero carbon is probably one of the biggest challenges of the 21st century. The use of modern technologies and innovative solutions are urgently needed to reach the common goal, and companies all over the world are investing and researching to find ways in order to tackle the global challenge to decarbonize the so important energy sector. Thus, we find ourselves in big times of changes. New approaches and solutions to transform the energy sector are needed more than ever. Green mining and green hydrogen, for example, are just two topics in which our Chamber of Commerce here in Chile is extremely committed to and is gaining a lot of attention in the last few months and years. Anyhow, these are just two buzzwords which 15 years ago probably no one would have taken notice of, and which nowadays are merely two symbols which exemplify the skyrocketing importance of the necessity towards a green energy transition. Areas and applications, like the use of green energy in the mining sector, are just one example in which the transformation is already accelerating in its pace. Generally, I and my colleagues, we are very happy that with RWE Technology International, we have a company which offers tailor-made and state-of-the-art solutions to tackle the problems of the global world now. RWTI is a company with which we work together since many years, and we're very, very pleased to call them a partner, finding solutions for our members and customers in the fields of decarbonizing the energy sector. In general, I want to thank very much the team of RWE for supporting us to enable us to organize such an interesting webinar, and we are very sure that the upcoming presentations will help you and your companies and your businesses to enter the world of a decarbonized energy sector. Now, I would like to hand over to Jorge Gayon. Before we hear again later for the closing remarks, I wish you all the best. Enjoy the webinar. Yeah, lots of fun.
Good morning, good afternoon, everyone. Thank you for this invitation. Very briefly, I wanted to introduce you to RWE Group, who we are, our capabilities, and to introduce as well RWTI and why we consider this to be our backbone for us, not only to grow, but to also foster and catalyze how we perceive this revolution in global energy. So a little bit of who we are. We're a power producer, but when we say that, it's a little bit of an oversimplification, and we wanted to put it in perspective. RWE has been producing for 120 years power. And to put a little bit of context into what happened 120 years ago, we were at the age of the explosive growth of the internal combustion engine. It was the first time where automotives became massified with Ford Model A, not even Model T, when the Wright Flyer performed the first controlled power and sustained heavier flight. The introduction of the typewriter. I was actually at the dusk of the typewriter when I was studying. Max Planck introduced the principle of the quanta that created the quantum. So you can imagine that RWE as a power generator has been leading and transforming and participating in the power industry across all these transitions. I think it's an oversimplification to say that we have been passionate about generating electricity, but now we're moving aggressively, if I put it this way, or with passion, into the new energy era. And to put a little bit of context, in 1976, as we, for the first time, started researching, understanding, and developing renewable energy. And by 2019, we became one of the global leading energy power producers in renewables. Now, a little bit of where we are. I'm sorry, I clicked the wrong button. We have, let's say, under that transition, we have 4 different, let's say, building blocks or operating businesses. The most important one, the 3 most important ones, I'm going to put it this way, directly linked to our power generation activities, are RWE Renewables. We are across offshore and onshore technologies. RWE Generation, as is defined here, which is the traditional or conventional power. We have gas, coal, hydropower, biomass, now moving into hydrogen. RWE Power, as I described, I mean, coal and nuclear, and this is a little bit of an internal organization. And the backbone to this capacity is RWE Supply and Trading, which has helped us construct and build not only the supply, but the offtake side. And as you can see, we're more than 20,000 employees globally. And the important thing here is that we are moving into the renewable energy space, as we're going to see in the next slide. But we have touched and we have direct expertise in every single generation technology available to mankind. And RWE TI has all that know-how built in through engineers and internal capacity available for companies that really want to take advantage of that know-how and implement greening solutions across any kind of technologies. You name it, coal, you have coal thermal, and others. Now, when I joined RWE last year, I came from a completely different sector. I come from the banking sector. And it was very interesting to me that the first thing that they asked me is, are you quote unquote a true believer? And I say, okay, a true believer on, let's say, renewable energy as the leading solution for decarbonization. And I say, yes. And someone say, okay, you're in the right place. And what do I mean by that? Right now, RWE has a clear goal, and is to be carbon neutral by 2040. And we are putting our money where our strategy, where our target is. And as you can see, if you look at the concentric circles on the left, I mean, we had now increased share of renewable energy in our portfolio. We are focusing heavily on offshore wind power. We're focusing a lot on solar, hydro, biomass, gas, you name it. And in the chart to the right, you can see the evolution of how our emissions have been reduced dramatically, and how are we targeting to become carbon neutral by 2040. And it takes, for me, a great level of pride to be an organization that it's focused on this transition. Now, a little bit of who we are in Latin America. We are part of what is called RW Americas. And Latin America right now, we have 40 plus staff focused on Mexico and Chile. The idea is to grow, but right now for development perspective, those are the countries that we're targeting. We're technology agnostic. We're focusing on onshore and offshore technologies. Offshore is led by a different team, which is our global offshore team, but the team that I participate in, we are helping RWE to grow significantly with over 2 gigawatts of power by 2030. And we're doing it in 2 different vectors. We're doing it either by greenfield development or by acquisitions. And right now, RWETI is our partner to expand with advisory services for power and mining companies, not only in Chile, Mexico, but also now in Brazil. We still don't have a mandate to operate in Brazil as we do it traditionally with Mexico and Chile, but they're being the tip of the spear trying to catalyze hydrogen decarbonization and other technologies. And one very important view of RWE in Latin America, it is that we have a buy and keep model. I mean, and we have all the capabilities and we interact in every transversal stage of project development, from, again, greenfield to development, construction, and operation. And that set us aside of the majority of developers that just are a little bit on buy and sell mode or looking for partnerships. So if you have any questions or if you have any interactions, if you want advisory from RWETI or you want to discuss further how we operate in Mexico and Chile, please feel free to reach out. Again, my name is Jorge Gallon. I am the head of partnering and transactions / asset M&A for Latin America, and you can reach me directly in LinkedIn. Thank you for listening, and now I pass to my colleague María Hurtado.
Thank you, Jorge. Bueno, me quiero presentar y aprovechar la oportunidad para decir unas palabras en español. Me gustaría aprovechar esta oportunidad para darle la bienvenida a todos a nuestro webinar regional para Latinoamérica, organizado en conjunto con las cámaras de comercio de la región. Como el evento es en inglés, ahora cambiaré de idioma nuevamente. Good morning, and I would like to welcome all our participants to our regional webinar, Decarbonizing the Energy Sector. My name is María Paula Arenas, and I'm a sales manager for Latin America and Africa for RWE Technology International. More specifically, in Latin America, I'm responsible for Colombia, Peru, and Mexico. So in case, or if you wish to have further discussions on business opportunities or on how can we support your company, please feel free to contact me. Now, briefly, I would like to introduce you to our first speaker of the day, Henning Josvik. Henning is an engineer and project manager with more than 20 years of experience leading international technical and energy projects. He's got comprehensive experience in developing, structuring, and executing of upstream projects with different energy sources like coal, lignite, gas, nuclear, photovoltaics, battery, and thermal energy storage, as well as recent projects for Power-to-X and hydrogen technologies. As RWE country manager for Bulgaria and Romania, he was responsible for the development of different RWE projects in those countries. As managing director, he was also the contact person for politicians and the industry. Henning is best known for his ability to think out of the box and find creative solutions for energy projects, and the ability to combine traditional technologies with innovative approaches. So, without further ado, Henning, the stage is yours.
Maria, thank you very much for the very kind and nice introduction. I will share my screen. Okay, so green hydrogen for climate neutrality. I think you already learned a lot about RWE as a company, and I want to build on that what George said. So maybe to give you more insights about our, let's say, our green ambitions we have. We have a very ambitious program to become a green company. We would like to invest more than or approximately 50 billion euros until 2030 in powerful and green generation capacity. And this relates to, let's say, approximately 50 gigawatts of green net capacity. And as let's say, two examples out of a lot of other examples, you can see here at the bottom side an example of a power station in United States, which is about 195 megawatts sorry. And also, for example, for a wind park or for a wind farm, which has a capacity of 1.4 gigawatt. There are a lot of informations available on the homepage at RWE, so feel free maybe to surf on that, or if you need, let's say, further information, don't hesitate to contact us. So why we are thinking that we are best positioned for the new energy world? We are, as also George said, we are well experienced in the power generation, with a very diversified power plant portfolio, starting, let's say, from the traditional coal, lignite coal, hard coal, over gas, up to nuclear power plants, and let's say also with a lot of, let's say, in the last years, with a lot of green energy sources. So when we started to become involved in renewable energies, we become very fast a global leader in renewable energies. So we had a very tough investment program in the past, and also with strong growth ambitions in the near future. And we have a proven track record in the emission reduction. This was, I think, also shown in a slide before from George. Our purpose is not only sustainable energy. No, we want to have, we want to produce energy for a sustainable life, and the ambition is to become net zero by 2040. It's not so far away, so maybe only a little bit more than 17 years left. So it's a very tough journey, which we will go. Why we think that hydrogen is key for the ambitious growth, and also for the reduction targets we have in Germany, and also in Europe, and also maybe hopefully in the world. And this is an example what it means here for Germany. You see that let's say the zero carbon hydrogen, so maybe hydrogen produced out of renewable electricity or green electricity, is very high until 2040. You can see here that maybe there are some, let's say, low-hanging fruits in the transportation sector and also in the industrial heat sector. So this might end up in a potential demand for hydrogen of approximately 500 million tons per year. This is a lot. Hydrogen is a very nice element. It has a lot of positive habits. You can store hydrogen so that you can use hydrogen as a storage for renewable energy. You can store it for long periods. You can use underground storage, caverns, etc. And also maybe hydrogen can be part of a global game. We will have soon maybe to produce it in countries where you have, let's say, a lot of renewable electricity available. You can produce it there and then transport it back to Germany, or maybe to Europe, and then use it there. I wouldn't say that it is essential that hydrogen should be produced only in Germany or Europe. Now, from my perspective, it's a global game. Here you can see where we stand. I think this chart is based on numbers from last year, but I think they are still valid, and maybe for me it is important maybe to transport the key message. There's still a way to go so that the green hydrogen becomes economic, or that the green hydrogen becomes very attractive for the companies to be used. On the left-hand side, you see the steel production. With a current carbon price of 50 euros per ton, maybe it's nearly half of the CO2 avoidance cost we have. So there's still a gap which has to be closed. And if you go to the right-hand side of the slide, you see that, let's say, the gap is becoming bigger and bigger, and this shows that there's, let's say, a huge need of, let's say, incentives for green hydrogen to become economic. On this slide, this is just maybe a schematic overview of what you can do with hydrogen when you link hydrogen to let's say to the power grid, which is fed by renewable electricity. In the center, you have the electrolyzers. You produce oxygen and you produce hydrogen. And on the right-hand side, you have, let's say, an example of potential applications for the hydrogen, starting with in the area of power to mobility, which is quite interesting from my perspective. And as we have seen in the previous slide, that the transportation sector has a huge potential to become attractive for hydrogen applications. So power to mobility is one point. You can put the hydrogen into fuel cell electric vehicles, but maybe also in combustion engines. And then maybe a bigger potential is in the power to industry application, where let's say hydrogen is, let's say, a core element and the basis for a lot of other projects in this industry. When we when we within RWE, and especially in Germany, talk about hydrogen, we are linked to green hydrogen. And on this slide, you can see that hydrogen has theoretically different colors, although hydrogen has no color, but maybe it is easier to bring to link a color to the hydrogen, so that you understand which is the electricity source out of which hydrogen has been produced. RWE in Germany is focused on the right-hand side, on the green hydrogen, and green hydrogen means it's hydrogen production only via electrolyzers, and the electricity is coming from renewable electricity. In other core markets of RWE, for example, the Netherlands or maybe UK, or even, let's say, abroad in the United States or whatever, let's say different types of hydrogen are also possible. We don't stick to the green hydrogen. This is, let's say, a special item for Germany. Coming from the left-hand side of the chart to the right-hand side, so when we talk about gray hydrogen, this is the traditional way of producing hydrogen. The hydrogen comes from steam methane reforming, and then can be used in chloralkaline electrolyzers. To be honest, this is at the moment, I'm not sure anymore because of the high gas prices we have, but this was, let's say, the cheapest way to produce hydrogen before the Ukraine crisis. I would say it was 2 to 3 or even 4 times cheaper than the green hydrogen based on renewable electricity. But this might switch if the gas prices remain on the high level as we see them now. Then we have the blue hydrogen. This is in principle the same procedure, using steam methane reforming, but taking the bad CO2 out of the process and store it into carbon capture and storage. Then we have the turquoise hydrogen. It's methane pyrolysis. It's let's say, I would say it's still in the research and development phase, although there are, let's say, a few applications or maybe facilities available to follow this way. Quite interesting, but still the technical readiness level is not so high at the moment. So until it will become economical, it will last still some years. The nice, let's say, feature is that we let's say get, let's say, carbon out of the process, so that we can store the carbon somewhere, wherever we want. And then last but not least, the pink hydrogen, which is related to hydrogen production based on a nuclear power plant. And this is, let's say, a hot topic, especially in France next to Germany. With this slide, there's, let's say, just a very schematic scheme showing that it's not so complicated to have an electrolyzer. You need green electricity, you need water demineralization, then you have the let's say the process cycle, mainly consisting out of, let's say, anode and cathode, and then you need power, and then, let's say, as most of you have been experienced in school, you get, let's say, on the one hand oxygen, and on the other hand hydrogen. You need after you have the hydrogen, you need a separator, and you have to run it through a deoxy generator, and then maybe you have to dry the hydrogen and maybe do some kind of a compression, and then here we are, you can use the hydrogen. You can produce each quality you want, let's say coming from highest quality and purities of hydrogen up to, let's say, normal hydrogen, which can be, let's say, put into a steam turbine or whatever you think about. When we talk about electrolyzers, at the moment there are, let's say, a lot of technologies available, but within RWE we are focusing on electrolyzers which are able to be let's say to be realized in projects beyond 100 megawatt each. And coming from this point, this means that we have to focus at the moment on the two most advanced technologies, which is the alkaline electrolyzers and the PEM, so the proton exchange membrane, which have a high maturity, technical maturity. Nevertheless, there are, let's say, different technologies available, but they are, let's say, in a younger stage and the maturity is not so high, so you can't realize project in the big megawatt size, and therefore we are focusing on the proton exchange membrane and the alkaline electrolyzers. And here on this slide and the next, I highlighted, let's say, some basics. What are the advantages and disadvantages? But I wouldn't say disadvantages, because when you make a electrolyzers project, I wouldn't talk about disadvantages, because each electrolyzer technology has its let's say, special features which might fit to your project. So on the one project it could be an alkaline, and in the next one it could be a PEM, who is the most economic one. Some main differences, for example, the flexibility, so maybe how to operate, because when we let's say put an electrolyzers and connect it together with a, let's say, with a wind park, we have always fluctuating load profiles, and then we have to see how, let's say, the electrolyzers can follow the fluctuating profile. The alkaline electrolyzers can do it, but not so fast as the PEM, for example. And the efficiency is a little bit higher in the alkaline electrolyzers, but I would say the alkaline electrolyzers has a big advantage because it's 80, 90, 100 years old. So there was, let's say, already a long journey to improve the technology and try to get the best out of it. And the PEM, let's say, did some kind of reset in the last 20 years. And I think the potential for improvement is higher in the PEM. And therefore, I would say the efficiency growth in PEM electrolyzers could be bigger than in the alkaline one. Yeah, let's say some other, let's say, characters and basics, which could be a reason for going for this technology, or maybe go for the other technology. So coming to projects, because I don't want to talk only about theoretical things. So I want to show to you that we are involved in a lot of projects. There are also, let's say, a lot of information available on the homepage of RWE. You can find the link on the right hand side. Maybe just to give you an impression here about our projects in Europe. I must admit that this is, let's say, only a selection of our projects, because we have, let's say, a lot of other projects in our company, but some of them are, let's say, confidential, and I can't disclose that we are involved, because we are also working for external clients and support them in their ambitions to become greener. So maybe to strengthen these activities, RWE has decided to have a dedicated board member for H2 at RWE Generation, and this is very good, because then, let's say, you have the right attention for the very, let's say, hot topic we have here, and this, let's say, is the right enabler maybe to position us in the hydrogen business in Germany, in Europe, and also worldwide, because we see that that hydrogen is key for achieving the national and international CO2 reduction goals, as I already said. So coming to our projects, we have a wide range. So we are handling offshore projects, and we are also active in onshore projects, also offshore and onshore projects with, let's say, different sizes. Before I will come to some details of the project in a couple of minutes. What I want to stress here a little bit is that it's when you want to develop a hydrogen project, it's not an easy game, because you can see here that it lasts maybe up to, let's say, 4 to 5 years to realize a project from an opportunity development until it becomes commissioned. And we developed here within our company a so-called stage gate process. You see that let's say we have an opportunity development, and after, let's say, the opportunity has a certain degree of maturity, we enter the ideation phase, which lasts 1 to 3 months, for example. And after the ideation phase, there's a stop, and we try to nominate the opportunity to enter the next level, which is let's say, early opportunity development for the next approximately 6 months, to increase the maturity and of the project, and to see whether it makes sense to follow or not to follow. And this goes, let's say, from the early opportunity into the next level for a mature opportunity until the project development. This is, let's say, the process. On the right-hand side, you can see the amount of project you need to become successful. Starting in the opportunity development with, let's say, 100% of the project, let's say, based on our experience, approximately 10% out of this will only be realized. And this is, let's say, a big burden, because you need a huge amount of projects which you develop, so that at the end you will have a successful project lying on the table. But then you have to, and then when you have ambitious growth targets, you can, let's say, derive from the numbers, what does it mean, how many projects you have. And this is shown here in this slide. What does it mean, let's say, for a goal of nearly 2 gigawatt electrolyzers capacity to be operated in 2030? We are now, let's say, in the year on the left-hand side in 2022, and you can see that nothing is commissioned. But this doesn't mean that we are not involved. No. Taking into account the previous slide I showed, that there's a lot of projects going through the stage gate process, and in 2024, or maybe next year, we will disclose the first projects which become commissioned. And then, based on the amount of projects we have, then you can see that the curve is growing very fast, so that we end up with 1.8 or nearly 2 gigawatt of installed electrolyzers capacity in our portfolio. But this is, let's say, this means when you theoretically want to have 1.8 gigawatt installed capacity running, you need, this is 10%. You can calculate how much, let's say, how big the project portfolio should be, you have to develop. And this is where we as RWE Technology come into the game, because we are able to support our RWE company and sister companies and so on, and also external clients in the whole value chain of a project. So coming, let's say, from a conceptual stage until the, let's say, commissioning of a power plant. And the reason why I showed this slide in different colors is that the light blue color is, let's say that there are, let's say, only a few projects in the most projects we are active in are, let's say, on the left-hand side. Nevertheless, as I said, the first success will become soon in the next 2 years, when we probably announce the commissioning of different electrolyzer power plants. But RWE Technology can offer services in the whole range, from conceptual study until the commissioning. here in a nutshell, maybe some of the projects we are working on. Maybe on the left-hand side, it's, let's say, one of our earliest lighthouse project. It's called GetH2 Nucleus. It's a big initiative in Germany to install the first 100 megawatt electrolyzer plant in Lingen. Lingen is a gas-fired power plant site of RWE, and we use this, let's say, this property to install the electrolyzer there. And yeah, COD is planned in 2024. Then we are also involved in different projects up to gigawatt size, always with, let's say, partners, to mitigate maybe the own risk and to push also the project forward. It's easier to do it in a consortium. And for example, this Aquaventus, it's also a very big initiative, an offshore initiative, where the target is to install up to 10 gigawatt of electrolyzer capacity in the North Sea. And the beautiful island Helgoland will serve as a central hub. So because maybe some of the wind offshore parks are more than 90 kilometers far away from the coast, and it's not possible maybe to drive and to go with a ship there within one day and do some maintenance work and come back. So we have some kind of a central hub on an island close to those wind farms. We have here, let's say, Ems Hydrogen on this slide. It's a 50 megawatt electrolyzer plant, also at an RWE power plant in the Netherlands. It's also very well developed and will also come to commissioning soon. Yeah, coming back to the GetH2 initiative we are involved in, there are also, let's say, further additional information available in the internet. The aim is that we build this electrolyzers plant on an existing power plant site of RWE, connect this electrolyzers with a wind farm in the North Sea, and then we are producing hydrogen. And the hydrogen is feed into a pipeline. And the pipeline goes into two directions. On the one hand, there's close to Lingen a refinery of BP, which will be served by green hydrogen. And there are, let's say, other customers more than 130 kilometers away from Lingen, which are also connected via this pipeline system to the plant. And then we put the, let's say, the green hydrogen into the pipeline, transport it over 130 kilometers to the customers in the Ruhr area. And this project, as I said, has been developed in a big consortia of, let's say, more than 40 participants, and the main participants you can see here on that slide, consisting of OGE, BP, Evonik, and Novega. And this project has started, I think, in 2019 or 2018, when, let's say, nothing was in place regarding rules and regulations in Germany. And this was also, let's say, a very important project, maybe to push the government into the hydrogen area. Here you can see how it will work. It's, as I said, a gas-fired power plant, and as you can see, the electrolyzers will be put there. The big advantage is that you can reduce your capex due to the fact that you can use the existing infrastructure and share the infrastructure, and this might help you to become more economic or faster economic with your project when you use existing infrastructure, because otherwise you have to put everything in place regarding the water supply, grid connection, and also the hydrogen offtake. So what does it take to develop a hydrogen project? It's partially very complicated, and what I see when I talk to customers which we support in their ambitions to become involved in green hydrogen, you have to be clear what you want to achieve. You should avoid doing hydrogen because hydrogen is, let's say, is a trend. You have to be clear what to do with the hydrogen. Sometimes, let's say, we are approached by customers in the middle of nowhere and they want to produce hydrogen, but there's nothing in place. There's not enough fresh water, or even, let's say, a pipeline where to put the hydrogen, or even to put it in their processes. Be aware that hydrogen projects are economically very challenging, and yeah, you have to check whether there are funding schemes or subsidies available. And this goes in line with, let's say, a close connection and contact to the government, because you have to convince them to help the green hydrogen to become economic, because right now it is a long journey to go. And then, to mitigate your personal exposure and the risk, build partnerships and alliances. Try to get everybody in the boat, from, let's say, from the upstream to the midstream until the downstream. And also, yeah, the customers should also be in place. Then you have strong forces to push things forward. Inspire politicians about the green journey you want to go, or the green hydrogen journey you want to go, and attract them. Tell them a compelling story, what you think, what could happen, and that you, let's say, that you are, let's say, the nucleus for further green hydrogen or green activities in the area. And as I always said, strive the Pareto principle with the right end experts to get fast answers, because at the beginning you will face so many questions, and be flexible in your thinking and try to let's say, modify and adjust your project. Yeah, and always what is, let's say, the last bullet is please think from the customer perspective. This is also, let's say, a key message I'd like to share with you. Okay, so I'm at the end of my, let's say, short overview of, let's say, RWE, how RWE wants to become green. What is a, let's say, hydrogen project, what is an electrolysis, and, let's say, a selected overview of let's say, our projects where we are already involved in. There are a lot of other information available on the homepage. Thank you very much for your attention, and I think now we have a Q&A session.
Yes, thank you very much, Mr. Josvik. Very interesting presentation, I think, also for all the attendees here, and quite, yeah, clarifying about some aspects, what is possible and how it's possible to develop the projects here. Nevertheless, we have some questions in the question and answer sections. The first one I would like to put here is from Matthias Medinilla. He wants to know, what are the next plans or objectives in renewable energy in Latin America in general, I would say, or maybe also from RWE. You mentioned some projects in the beginning.
To be honest, I'm not, let's say, the expert for renewable electricity or energy in South America. This is, let's say, where I'm not coming from. I know that, let's say, there are a lot of markets which are, let's say, of high interest for us, and which have a very interesting, let's say, wind profile, or maybe irradiation to install PV. But let's say, I'm not the South America expert, so I can't answer this question appropriately.
Okay, so we try to derivate it to someone else. Next question would be mainly, what is the factor that affects the current price of hydrogen production? Thinking about what is the opportunity to lower the price?
Yeah, maybe when you want to produce 1 kilogram of hydrogen, you need, let's say, between 55 or maybe even 60 kilowatt hours of electricity. So maybe the electricity is, let's say, a main cost driver in the OPEX, and therefore, let's say, the efficiency of the stacks. And this is, let's say, one thing where we or maybe the suppliers should become more efficient, yeah, to increase the efficiency of the stacks. This is the main driver. Let's say the other surrounding infrastructure is, let's say, these are standardized products. When we talk in demineralization, it's not a rocket science. So maybe these prices are doesn't have a big let's say, potential to be increased, but let's say the core, the heart of the electrolyzers, there, let's say, I think a lot of things are possible. And of course, when we look at the infrastructure, when you, let's say, have to do some, when you need a minimum pressure of the hydrogen, for example, when you want to feed it into a pipeline system, the compression of hydrogen is also a very expensive one. But also, as I said here, and this is also valid for compression and demineralization, these are standard products, where the potential is not so high, but let's say, the core, the stack is the one with the highest potential.
Okay, thank you. The next question would be, what do you think, which role can Latin America play in the global demand for hydrogen?
I think maybe, as I said, hydrogen will, from my perspective, hydrogen will become a global game and a global market as well. And I think we have to go there where, let's say, the hydrogen can be produced as cheap as possible, and then hydrogen can be transported somewhere else. And we shouldn't close our eyes for, let's say, hydrogen derivatives when we want to transport it. Maybe ammonia could be an option, so that you produce the hydrogen in South America, you convert it into ammonia and bring it to, let's say, North America, or maybe even to Europe. And then you can use the ammonia for, let's say, different purposes. You can crack it and use the hydrogen, or you can bring it directly into to the industry, because the demand, especially in Europe, for ammonia is very big. And therefore, we have to see, especially in Chile, let's say, what are the wind profiles for renewable electricity. If this is very cheap, this is a very good basis to produce green hydrogen. And I know that, let's say, from my discussions I have, that there will be a market for green hydrogen. There will be a market for green ammonia. There will be a market for green products, even steel, for green steel. There will be a market, and some of the customers, and or even some of the customers are willing to pay some kind of a premium if they can brand their product as green.
Perfect, very interesting. So yeah, let's go to the next one. That is a bit linked to it. How can this role of Latin America be actively supported by RWE Group, or is it perhaps already being supported?
My colleagues are active in, or maybe Tobias, would you like to answer?
No, I can do so, Henning, but also you can answer this. But I thought I noted down all these very specific Latin American questions, and maybe I can support the answer here. For your information, I'm Tobias Metzger. I'm heading the sales and business development of RWE Technology International. So regarding these questions in specific to Latin America and the conditions there and so on and so forth, as Henning already said, when we come, what would be the trend in renewable energies in Latin America? In my opinion, as in every country and in every region of the world, you cannot say it. The trend is wind, the trend is photovoltaic, the trend is whatever. The question, very special in these renewable energies, is always what is the condition in the specific site, not even in the specific country. Because if you look, for example, in Chile, very long stretched, completely different environmental conditions in the north than in the south. And most or a lot of the countries in Latin America are huge compared to the smaller countries in Germany or in Europe. And therefore, it really depends on where are the wind conditions, onshore, offshore. Then naturally this would be wind. Where is the solar radiation? This is would be photovoltaic, probably, or maybe even concentrated solar power. It really depends on. In general, Latin America, going from Mexico down to Chile and Argentina, already has a very, very high share of renewable energies, mainly based on hydropower, which is great because it's a comparably stable renewable energy on the one hand. On the other hand, a lot of the hydropower sites are already utilized, especially large-scale hydropower. There are also environmental and social concerns. I guess you all know about this. So most likely it will be wind, onshore, offshore, and also photovoltaic. And that also comes to this role regarding the hydrogen of Latin America. In general, and again, it depends on which country and even which region within the single countries. In general, the precondition to provide cheap hydrogen, and that is what Henning already said, it will be a global commodity, and for global commodity, it's always the price, and the reliability of supply. In general, most of Latin American countries do have a very, very good basic conditions for producing of especially the green hydrogen, because there is a high potential for renewable energies, all sorts of, be it the hydro, be it the solar, be it wind, onshore, offshore. And in many of the countries is also water available, which, for example, a lot of ideas going in, produce green hydrogen, for example, in the northern African region. There is a lot of sun, Sahara Desert, but what they don't have is water. And that it's very similar in Australia, actually. And that is something which very often is forgotten. And in this respect, there is, in my personal opinion, and also what we realize, the technical conditions for green hydrogen in Latin America, all over from Mexico down to Argentina and Chile, are in general very, very good if you compare it to other areas. However, Henning mentioned this also, it's and this is all over the world, and it's the same in Latin America. For the time being, such a new technology as green hydrogen needs a lot of effort, technical belief, and also financial, and that this is where politics come in, and politics in each region of the world is always an issue. And there the question is, okay, who is supporting, or which country would be supporting, well, fast on, and also in a very clever way. This again brings us to the third question. So how does RWE, or how can RWE contribute? As you heard from Jorge Gayon at the beginning, so RWE as an investor and project developer is already active in Mexico and in Chile, where we develop renewable energy projects of various technology, wind and photovoltaic mainly, and where we also look at the production of hydrogen, green hydrogen. So that is really as investors, and for the other countries, and also for Chile and also for Mexico, but also for Brazil and Peru and Colombia and Uruguay and whichever other country there is. We as RWETI provide the know-how that we have, and we have as an operator and investor ourselves, and that is probably a unique position that we have in the world, because other than other consultants or advisors or engineering companies, the know-how that we have is basically collected from RWE's own investment projects and development projects. Also, when we look at the second presentation in a couple of minutes, what we also have is still a lot of mining experience, of these still very large lignite mines that we still operate until the coal phase out in Germany in a few years. And nowadays, and I think this is very interesting, especially for Latin America, because a lot of the countries do have large mining activities, Chile, Brazil, to mention, also the other countries, most countries in the areas are rich of natural resources. And nowadays, and this is quite interesting, the energy supply of, well, the country as such, to supply electricity, and the decarbonization and electricity and energy supply of the mines, and especially the very large mines, are getting closer and closer and overlapping more and more. And this is again where RWE and specific RWETI can bring in and is happy to bring in the know-how that we have as a power generator, as a producer of green hydrogen, and also as of a large mining company. But there are more questions I do see, so probably I should stop
Yes.
talking here.
Well, thank you very much for answering that one, Tobias. I think that was a very good, extensive answer. But yeah, there's a lot of more questions. We cannot answer all of them, but I would like to put especially one question that is more recent to Henning Josvik. It is very impressive that we have a lot of investment on new projects, even though we haven't seen a big commission plant operating yet. What security do companies that want to invest in these kinds of technology can expect for the real output after commission versus the projected output?
I'm not sure whether I get that question right, but okay. So maybe I think the question is maybe there's let's say a planned output, and when the project is realized, then there's let's say a real output. This is what I understand. So yeah, it depends on the let's say on the quality of your base of design and of your engineering competence you have. This is a very, let's say, a very good question, because the gap shouldn't be so big. And during, let's say, each project development is a journey. It's a journey, especially in the hydrogen business, that, let's say, both sides are learning. We, as let's say, as an operator, and also the supplier is learning, because it's not a gas-fired power plant which you can buy wherever you want, and let's say which has been built thousands times in worldwide. No, electrolyzers is, let's say, quite individual, and it depends on the quality of the project development and you do, and also the base of design you do. And the reason for this is, for example, give you an example. We as technology, or maybe as RWE, will commission the first electrolyzers within the next 2 years. And we, at some point of time, we decided to build a pilot plant, just maybe to get familiar with the technology and to start at very short notice, let's say in a smaller scale, gaining experience on how to develop and operate electrolyzers. And this was a very good decision, because we learned a lot for the, let's say, for the bigger projects, to reduce this potential gap which might happen when you do a bad engineering.
And that's maybe I need to switch in again, yeah, because that's indeed a very, very interesting question, and that's an interesting question also for RWE as an investor in such plants itself. Traditionally, I guess it's the same in Latin America. Traditionally, companies like RWE, utilities, and also the large mining companies are very, very, very risk averse. Henning Josvik mentioned already the example with the gas turbines, when RWE invests in a large conventional power plant in the past. Yeah, the first or the second question was always to the OEM. Yeah, how many operating hours does this technology have all over the world? And if it was too little, then RWE and most utilities were reluctant, yeah, and took the one that was maybe a little bit less efficient, but had a higher reliability because it could prove it. Now, yeah, there is a race ongoing, and companies need to invest a hell lot of money into a technology. Nobody really knows whether it works in this huge scale everybody is talking about. And therefore, comes again the subsidy issue, what we mentioned before, and also what Henning Josvik mentioned before. Look for partners, because everybody, either or both on the producer side as well as on the consumer side, they have the same issue. They need to do to sail into the blue, that's what we say, like Christophorus Columbus 500 years ago, when he coincidentally found Latin America. You don't know what is at the horizon, but you still need to do it, because somebody somehow the entire world. And if you look for partners, the risk is somehow shared. And as again, you need, and that is what Henning also mentioned, get the politicians involved, look for whatever additional subsidy and funding scheme. This is actually to reduce the risk as good as it goes. And as we did, go into very detailed discussions with the OEMs, with the developers, start your own pilot project, or look for somebody who did it. But these pilot projects, they will not run as in previous times. You build a pilot project, you operate it 10 years, you do an evaluation, and then you decide you go on. Here it will be a pilot project, and by the time the pilot project runs, you already started a couple of big projects, and you need to go on a fast track. And you need to learn in parallel and directly involve the learning into your new or ongoing bigger project development.
Perfect. Thank you very much. Very helpful answer, I would say. And I would put the last question, which is also a bit related to that. We only have 2 more minutes, but I think it's possible to answer that. Is RWE interested in entering green hydrogen projects in early stage phases in Latin America? What are possible partnering structures RWE might be interested in?
Maybe this again, a question for me, or Henning, do you want to answer?
Yeah, maybe I can answer it shorter.
Okay.
No,
you got it.
No, yes, we are interested in projects also in a very early stage. And when there's, let's say, no one, let's say, corporate concept we want to follow, we are flexible. It depends always on the project, how we can be involved. There are, let's say, different options possible. We are quite flexible, and what I can say is just send us an email, and then we are, let's say, able to discuss it directly with you. So we are very, very flexible, because let's say in the last projects we made, there are, let's say, different types of corporations realized.
Perfect. Thank you very much. That was a perfect answer for that in terms of time. And yeah, we have to close the Q&A session for now. Maybe it's possible you can answer some of the questions in the Q&A section by typing it. We'll see. Yeah. And now we continue with the next presentation.
Thank you.
Thank you very much.
Thank you, Christoph. Good morning to all, and how you say in Portuguese, bom dia e bem-vindo à segunda parte sobre os desafios da indústria de mineração. And for the Spanish-speaking participants, buenos días y bienvenido a la segunda parte sobre la minería. My name is Max Christian Ping. I'm sales manager at RWE Technology International for Americas and Africa, with a special focus on Brazil and Chile. I'm part of the team now for around about 1 year, and I have a strong connection to South America. First of all, my wife's from Venezuela, so I had to learn Spanish. And second, I had the chance to live a few months in Brazil, in Sao Paulo, where I wrote my bachelor's thesis, and had the chance to learn Portuguese as well. Before I continue, if you would like to talk further about today's topics, you can contact us and find our profiles on our website, which is worth a look. So now it's a pleasure to introduce my colleague, Andreas Kutsch. Andreas is working as mining engineer at RWE since 2013 in various open cast mines in the Rhenish mining area, mostly in the production development. In 2019, he moved to RWE Technology International as mining consultant for South America, with a special focus on feasibility studies, mine planning, equipment design, training, and knowledge transfer in the field of continuous mining technologies. He had several long-term projects in Brazil, so he also learned Portuguese. To briefly introduce and tease the coming presentation, at RWE Technology International, we see 5 different challenges in the mining industry that need to be tackled in the coming years. These challenges are the following. First, net GHG emissions, and how can they be reduced? This can be a question on the one hand between hydrogen and on the other hand the IPCC. We already heard a very interesting presentation from Henning about hydrogen. I will talk about further possibilities for decarbonizing the mining industry. Second point is air quality and especially dust emission reduction. In this presentation, we'll show the most effective ways for dust reduction with experience from our own mines and projects worldwide. The third point is mineral residual skills and safe dry stacking. We'll show some examples from our own stockpile constructions in Germany and how we solved the problems we had. The fourth point will be the biodiversity and how we realize rehabilitation at our own mines since now already many decades. And last but not least, water utilization, water treatment and acid drainage as focus. So we'll hear a presentation with many interesting topics, and now I'm pleased to hand over to Andreas.
Yeah, Max, thank you very much for your introduction. Good morning from my side. Good morning to where you are at the moment. I'm actually in Brazil right now, and not in Sao Paulo, by the way, but in a much more remote location. So my internet connection is probably not the best. So I will cut my video feed just to save some bandwidth for what I'm going to show you right now. So please bear with me. So what I would like to talk to you about today is how we as RWE would like to efficiently solve what the mining industry is facing at the moment and in the near future about environmental challenges. And Max already anticipated some of these challenges that we are facing in our own operations, but also with clients worldwide. Why mining industry? And I think maybe in the beginning, Jorge was pointing that out quite briefly, but let me tell you in more detail. RWE actually has a quite long history in mining itself. So maybe almost as long as the history of RWE itself, there has been mining in our business. And there was mostly coal mining or lignite mining in Germany, in very large scale open mines today, but there's a long history in the mining and in the technology in particular, in the technology of continuous mining operations. So that involves basically conveyor and large scale mining machines. But we as RWE or as RWE Technology not only have our own mining operations, but maybe almost 60 years at the moment, we're also working in providing our experience, our know-how for clients worldwide. And Latin America, in particular, has been our focus for a very long time. So we have locations in Chile and Brazil, and we are having projects in other countries in Latin America as well. As Max was pointing out in beginning, is that we are facing, or the mining industry in general are facing several issues at the moment. And I think the most prominent one, of course, is greenhouse gas emissions. Maybe that's not clear to everyone, but the mining industry itself is almost or is responsible directly or indirectly for almost 1/3 of the global greenhouse gas emissions. So that includes scope 1 and scope 2, so the direct emissions from the operation, and scope 3 emissions of the use of the material in the value chain later on. So in this instance, we have a lot of pressure from government decisions, but also from non-government organizations on all kinds of mining activities worldwide to reduce greenhouse gas emissions and to incorporate new technologies like hydrogen or like electrification of equipment. And actually, basically all major mining houses worldwide have committed to reduce their greenhouse gas emissions in the coming years and decades. So other topics, nevertheless, are also quite important as air quality, and especially in operations that are quite close to population, to villages or other infrastructure, the air quality aspect and the reduction of dust emission plays a huge role in in the strategy of these operations. The same goes for waste material. So what to do with the waste material, and right now and in the future, of course, we will have a lot more waste because deposits gets deeper. You need to dig more material to extract the minerals or the coal, and that involves a lot of movement of waste material. And how to store this material safely and feasible is one of the challenges that the houses are facing at the moment. And the same goes for biodiversity. It's not only about guaranteeing a good biodiversity in the current operation and in the future after operations have stopped, but also to guarantee that the landscape is getting transformed back and recultivated back into its original state, which has been a huge challenge for our operations in Germany, but more and more countries react with stricter permits or stricter legislative tools to guarantee that the biodiversity is guaranteed in the operations. And last but not least, and that is not only a challenge for rather dry countries as Chile it is, but also for all countries to utilize the water in a feasible way and to guarantee that water doesn't get polluted or polluted with any kind of chemical substances. So I would like to start with the major topic in this presentation, which would be greenhouse gas emissions. And as Mr. Josvik already pointed out, hydrogen will play a huge role in all kind of activities, industrial activities worldwide, and mining is no exceptions. So there are a lot of activities at the moment to incorporate hydrogen into the available or future equipment being operated worldwide. And this is basically replace the fuel that trucks and excavators are based on, from mainly diesel up to hydrogen in the future. But of course, hydrogen comes with some disadvantages. And the first one is, of course, you need the infrastructure. And the infrastructure to transfer hydrogen to remote locations, which mining basically operates in, is a challenge in itself. So on the other hand, we have electrification. That could be, on one hand, of course, battery-powered trucks and excavators, which is also in the pipeline for the coming years. And all major OEMs are looking into this technology. But this technology itself comes also with disadvantages, which would be, for example, the low energy efficiency of batteries in general. And that means either a lot of new investment into a huge, bigger truck fleet, or that could be technologies that are not really proven at the moment, like changing batteries in the production process. So there are also some disadvantages. And the third technology, also based on electrification, is to either plan new operations directly based on in-pit crushing and conveying technology, so incorporate more belt conveyor into the strategy, or to restructure a mine based on this technology in the future. And maybe, as you're familiar with, the certain or the current technology that a lot of mining operations are based on is shovel and truck. So you have an excavation phase, you have drilling and blasting, extraction, and then transport of the truck either to the waste pile or to the plant that the mineral or coal is being treated in. And the first step to incorporate belt conveyor, so electric powered technology, into that system is to use intermediate crushers in the operation very close to the actual excavation front. And these crushers can be either relocated from time to time or being located permanently in this location. And by this shift to this technology, reduce both the vertical and horizontal distance that the material has to go. So that's basically the first step, and this is actually what is being used at the moment quite regularly worldwide, especially in Chile and Brazil. That would be an example of a semi-mobile crushing facility. So as you can see, it's a usual dumping process into the crushers, in this case jaw crushers, that crush the material and convey them onto the belt conveyor towards the point of the location that it has to go to. And if we're talking about even more drastic version of this approach, input crushing and conveying, would be the fully mobile system. And in this system, as you can see in this slide, trucks are eliminated entirely. So an operation that is operating in this kind of strategy doesn't have any kind of diesel-powered trucking equipment. So that's already a huge reduction in the emissions that diesel is involved in. But that still leaves the excavators being powered by diesel. But of course, there's also solutions for this challenge, as excavators are being powered by electricity as well, can be incorporated. So if you have that kind of technology, as you can see in this picture, which is the S11D mine in Brazil, which is entirely based on continuous equipment, you basically eliminate all kind of diesel equipment, with exceptions of, for example, road development, maintenance, etc. But the main equipment is being electrical powered. So what is the advantage of going electrical? As you can see in this chart over here, we did a comparison based on several studies from worldwide operations, what the actual power usage is for both kind of technologies. And as you can see in the green lines on the bottom, that represents what theoretical is possible with a belt conveyor in certain kind of slope grades on the x-axis, and in comparison, the straight line, the straight green line, that represents what an actual operation, in this case our Hambach mine in Germany, can deliver. So these curves are actually quite close and represent a rather low specific power consumption. If you then take a look at the blue lines, the dotted and the straight blue lines, this is in comparison what trucks, of course, recalculated in kilowatt hours per tons in kilometers, would consume in specific grades in the transport. And what OEMs generally don't tell you or don't tell to customers is that trucks are usually influenced by a lot of circumstances in the operation, be it the road quality, the grade, the quality of the tires, and so on. So there are several influencing factors that actually affect the power consumption. And what we could see in different studies from Australian operations, in this case, what the theory would show. So when we take a look at a comparison between TEX, which stands for a shovel and truck, so really conventional operation, versus a fully mobile input crushing and conveying system, and base it on a quite typical European power mix, which would be 1/3 renewables, 1/3 gas-powered, and 1/3 coal-powered, there you can see that in this power mix, the greenhouse gas
I don't hear him anymore.
On the left-hand side are already considerably lower operation would pose. If you then take me, hello?
You were interrupted, but now we can hear you again.
Okay, I will continue and let me know if you have any issues, please.
Yeah,
So going back to going back to that slide, what I was talking about in the last few seconds is the greenhouse gas emissions in that comparison are based on a rather usual power mix or a grid power mix like you can find in most European countries. If you take a look at countries like, for example, Brazil, which has more than 85% of hydropower in its energy mix, that advantage would be even higher. So the greenhouse gas emissions is one very important factor taken into consideration when you're comparing those systems. If you take a look at the investments being needed to incorporate such a system, so the CapEx, that in general involves quite high initial CapEx for the whole infrastructure that is needed. In this example, theoretical mine, in this comparison. The reinvestment, so the concurring investment in the later years, is on the other side even lower than a shovel and truck operation. So if you take a look at the total investment, that is basically on par with each other. So there are not a lot of differences. The OPEX, on the other hand, is considerably lower between the blue shovel and truck operation and as you can see on the green side of that chart, the fully mobile equipment in this IPCC configuration. Of course, it's not only about greenhouse gas emissions and the cost being involved, but there are a lot of key factors or key points to consider when comparing those technologies. And this is mainly influenced by the geology of the deposit you're working in. So there would be deposits that are very suitable to incorporate IPCC equipment configuration. On the other hand, there could be geological constraints that that rather forbid to use IPCC, and shovel and truck would be the most favorable solution. So that is one factor. The masses itself, so how many tons do I need, or does the operation need to transport, plays a huge role, as generally IPCC is being used in high production operations in comparison to low operations that are probably not suitable to IPCC operation. The OPEX and the CAPEX are already talked about. That is one important point in the strategy of mining corporation to consider, as the fast return on investment is on the other hand not the easiest thing to do with an IPCC operation, as this needs more life of mine, so a longer life of mine to amortize over time. And then, of course, we have the environmental impact and the social impact. And the environmental impact, as I already talked about, is a big advantage for IPCC in general, as CO2, but also dust, water, and noise can be controlled much better compared to a shovel and truck operation. The social impact, on the other hand, is based on the fact that operation with a lot of continuous equipment requires less employees. So this is about cost of operation, but also social impact, as this may be the case in remote locations where skilled employees are not available at all times. And last but not least, safety, as a fully continuous operation, has a lot of automation and innovative technologies compared to trucks that are always interfering with the traffic inside a mine. So the safety is one clear advantage for IPCC. So I already pointed out dust emissions is another point, or air quality in general. And from our experience, or what we always try to do in our operations, is the most economic way to just avoid creating dust. And there are several ways how we can do that. Or if you can't avoid creating dust, at least limit the dust interrogation into the air at the equipment. And that can be done by replacing, as I said, trucks via conveyor belts, which are much better suitable for dust control. Keep the mining equipment and all kind of activities clean and well maintained. What is always a very good way to control dust emissions or to limit the impact on the environment is to use greenage like trees and plants even in the operation itself, to bind the dust and to limit the impact. And last but not least, to utilize dust suppression systems like belt scrapers or use water-based belt cleaning equipment and cleaning equipment in general. One example how we solve that issue of the dust emission from belt conveyors is to use systems that bind the dust at the source. So what you can see here in this chart is a scheme of a belt conveyor chute. So one conveyor goes onto another one. So there are a lot of systems that can be incorporated to bind the dust or to collect the dust, like scrapers, like high pressure belt cleaners on the return strand, like this extraction tunnels that try to bind the dust at its source and to remove it from this extraction tunnel. And this is actually more complicated than it sounds, no? As water is not water in each instance. So does a lot helps a lot? Basically, no. It depends on what kind of technology is incorporated in this kind of strategy. So in general, dust binding is based on the size of the water droplets being used, and smaller droplets, like on the right-hand side on the picture, as you can see in this instance, this is much better suited to bind the dust and to collect it on the ground compared to just large droplets, for example, from a water tube. So the next three topics that I mentioned, waste material, biodiversity, and use of water in general, that is combined into the next chapter. And I would like to start with waste material. As I said, the stripping ratio in operations worldwide are getting worse and worse. That has to do, of course, with the lower grade of the ore, the deeper location of deposits, and the location of the operation itself. And one very good example how, in our experience, waste should be handled in a safe and feasible way is the example you can see on this picture, which is the Sophienhöhe, which is one large waste pile in one of our operations that at the moment has a height of almost 200 meters with another additional 400 meters into the mine you can see on the right-hand side. So that is a structure of almost 600 meters that has been built by spreaders and belt conveyors, and it's still very stable and also used for reclamation purposes, as you can see on this picture. And to guarantee that those kind of structures can be safe and stable in the long term, that is actually much harder than one would think. In this instance, we use different kind of technologies to guarantee that the structure will be stable for a lot more years, up to the ending of the mining activity in this mine. And what you can see on the bottom side is how we construct these piles with different kind of materials. So there's rather stable material involved, rather stable waste material, and rather unstable material. And of course, the operation and each operation has to dump this material where it should be dumped, of course. And what we do is a kind of honeycomb structure where the spreaders work in different kind of operation modes to guarantee that this red or brownish material stays where it is and doesn't move at all. On the other hand, we also have to guarantee that the water drainage is always guaranteed in this waste piles, as water usually, and a high water content in a waste pile like this will create an updraft, and this has to be prevented at all times. So when we talk to customers how this kind of technology can be incorporated, we first take a look at what kind of material is actually available in a mining operation. And it highly depends on a lot of geotechnical constraints, like the availability of the material, the structure of the deposit, and the water content that the waste material is made up, and if the equipment is actually able to create structures like this. So that has to be taken into consideration when talking about a safe construction of a waste pile. And especially after the Brumadinho disaster in Brazil, a lot of customers ask us about this kind of approach. And we always tell them, take a look at what we do in our operations. Let's think about how this can be incorporated into the client's operation and what kind of equipment is needed to guarantee such a approach in their operation. And this should be done as soon as possible in the planning phase of a new operation, as this determines how it can be done later on. So for the rehabilitation part, I would like to show you this picture, which is a satellite picture of the Rhenish lignite area in the western part of Germany. And what is really important to know is that German legislation requires each mining company to come up with a plan from the get-go how the rehabilitation after ending of the mining activity should be done. And on the right-hand side, you can see that may be more than 20 or 30 years of difference between the initial planning phase and the actual completed recultivation. So what is always important for us and for clients worldwide is to consider how the material that the rehabilitation and recultivation is later based on should be stored and should be dumped later on onto the surface. Another aspect is, of course, what kind of vegetation can be actually planted in the new kind of landscape, and if this vegetation is suitable for the specific region that is used in. In some instances, we also have the challenge of waterways, like channels, like rivers, or even lakes that needs to be relocated because they're just in the way of the mining activity. And a really successful example of this kind of relocation can be found in the right-hand corner, where actual real river has been relocated to make room for the mining activity. And those are almost 20 years of differences in this picture. And as you can see, this river is well and alive and has also attracted a lot of species afterwards. To give you an example about the actual area that we're talking about, there are almost 300 square kilometers in this Rhenish area from RWE, and almost 220 square kilometers are already rehabilitated or recultivated, which is basically farmland, forest, but also other uses like walkways, like paths, like leisure activities, and so on. And on top of that, we're talking about over 3,000 animals, species, and many thousands and hundreds plants that have been successfully relocated in this area. So just in the outside dump that I was showing you some slides ago, we're talking about 10 million trees that have been planted in this location. So about the water use, it's very important to consider how much water actually has to be drained from an operation and what could be the use of that water. Is it only water that's being used for discharge into rivers to lead it away from the operation, or can it be used, for example, for cooling purposes, in this case, for drinking water purposes, or especially for protection of habitats? And this flow chart over here shows the general quantities that we're talking about in the RWE mining area. We're talking about more than 500 million cubic meters of water drainage and dewatering every year, and the corresponding shares that this water is being used in. Also, a very important factor when talking about drainage of mining operations is how does it affect the wetlands or the basically the vegetation in the surroundings, as in general you have a lot of, or you have a huge area that is being affected by this drainage activity. In this case, it's one part of our mining area, and as you can see, there are a lot of in this blue lines, there are a lot of measures that have been done to guarantee that not only the wetlands are being supported and doesn't get dry in the future, but also the drinking water supply of the nearby country, villages and cities is being secured. So that was actually it. Thank you very much for your attention, and I would be happy to answer all of your questions.
Thank you very much, Andreas, for those interesting insights. It was a great presentation concerning the green mining topic. My name is Yannick Weiss. I'm a project manager for energy, mining and sustainability at the German-Chilean Chamber of Commerce. And we don't have any questions in the Q&A section at this moment. So I'm asking everyone that has a question concerning green mining to put up their questions in the Q&A section. But for now, I have a question for you anyways, Andreas. So I would like to know, on slide 11 of your presentation, you talked about the tax versus IPCC systems with FMC, so the trucks and shovel with IPCC versus IPCC systems with a fully mobile convoyer. So you have already implemented such a system in Hambach, Germany, for example, in the Pelambres mine in Chile as well. And I would like to know if this system is replicable in any open pit, any open mine, or not.
I would like to answer with the usual answer, it depends. And it depends on certain aspects that I was showing in another slide. But I think most importantly for any kind of company that considers to use that approach for their operation is to do that as early as possible in their planning stages. As once a certain plan has been set and especially certain equipment has already been considered or even bought, then the implementation gets harder and harder. So corporation really needs to incorporate that idea and to admit that all the downsides, like a higher initial investment, will pay off over time. But the company needs to really admit that this is part of their strategy. And of course, if there's a certain geological constraint that prevents the use of that kind of system, we as a consultant would be as honest and say, okay, maybe in your specific corporation or operation, that kind of technology doesn't make sense. But maybe let's try to find a solution that could fit in anyhow. So we have to be honest about what is actually possible, and the client has to be open to incorporate this.
Perfect. Thank you very much, Andreas. I'm seeing that there's some questions coming up. That's great, but I'm going for this one. I mean, Carlos Tapia's questions has been kind of answered right now, which was similar to mine. But I'm going for the next one, which is, do you know if there's any other country outside of Germany with a rehabilitation area in Latin America?
Yeah, of course. There are a lot of examples about the need for rehabilitation, or let's call it recultivation, in South America. And I think at the moment the legislative side of that aspect is getting more and more strict, as the government also would usually would like to make use of that land that the operation is based in at a later time, but also being forced, not being forced, but being motivated by, for example, non-governmental organizations that really observe how mining companies care for their operations later on. So there's a certain pressure in actually all kind of countries worldwide to make better use of rehabilitation in the operation itself and in later usage. And there's a huge motivation to look for solutions, what is actually possible. But again, as I said, this has to be included in the strategy as soon as possible, as usually when you take a look at this aspect later on, after the mining activity has stopped in a certain location, it's much harder to include these ideas and these technologies, and maybe also the material that is being needed for rehabilitation as compared to in the beginning of a mining operation.
Perfect. Thank you. There's another question that came up from Alfonso Duran. He would like to know if any of the solutions incorporate the use of hydrogen and how that would work out.
Yeah, well, the equipment that I was talking about, basically continuous equipment like crushers, like mobile crushers, like belt conveyor, those are of course powered by electricity. But there are solutions. It's also, I think, in a very early stage, but nevertheless, the idea is there from a lot of mining companies to include hydrogen in electricity production on site. And I think that could be a very good solution for very remote locations where maybe the electrical grid is not developed enough to guarantee that that the power supply is sufficient for the operation. If we're talking about countries with a high developed energy grid, I think the way to go is to directly use electrical energy from hopefully renewable production in order to guarantee that the operation has a very low carbon footprint.
All right.
But also, if I may add?
Sure.
Yannick, if this is fine. Even if we learned before when Henning was presenting about the hydrogen issue, as you may have realized there who joined this or who participated, there are so many open questions still regarding the hydrogen production. Then there is the hydrogen price, and there is this. You also need electricity. You also need electricity for the hydrogen production, or you need to transport it to this probably remote area, which also is a question which is basically not solved. How to transport it in these huge amounts that would be required. And also, I don't know whether there are some of the participants here There are some projects in Chile ongoing and also in South Africa. You probably know about them. Pilot projects from large mining companies and also in Australia for utilizing hydrogen for the diesel substitution. And what I heard from the one or the other is that it works, but there are still a lot of questions, and also well, a mine is a dirty thing. There is always dust. The plants are running 24/7, 365, and the technology for the hydrogen is it's a sensitive issue. All these electrolyzers, all these fuel cell things, and so on and so forth. So there's always the question: okay, will it be really the right thing? And again, as Andreas mentioned, I think in the end it depends on, and you have to look at it case specific and mine specific and site specific.
I think at the end we're also talking about a supply issue, both in terms of hydrogen and batteries. And due to basically the worldwide trend to use more and more batteries, especially in the automobile industry, there's a very huge demand for the resources that are needed for supplying batteries. And this in itself is a constraint, again, for the mining industry, as they want to incorporate technologies like hydrogen, like batteries. But I think the supply is very limited. And the use of electrical powered equipment, like, for example, conveyors, I think is one solution to solve that issue with the supply. But nevertheless, the conditions have to fit. It's not a solution for everything. That is clear.
All right, perfect. Thank you very much. I believe we have time to answer one more questions, and I would go into a little other direction at this point, and would like to know, well, in order to operate a conveyor, for example, there's a certain expertise that is needed, and I would like to know if RWE offers any expert training operating those systems, and how is this procedure in this case?
No, very good question. That is one of our services that we do a lot, especially in the recent years. And the reason is, as I said, now our experience goes quite far back into the past. So we have specialists in all kind of topics in the overall topic of belt conveyor usage, being it maintenance, being it design, operation, and spare part management. And this very specific knowledge is required if you would like to use the technology in a feasible way. So what we do about trainings is, in the first step, we are trying to identify what is actually needed. So if a customer comes to us, okay, we need more skills, more knowledge in our operation, we identify, okay, what is the actual topic that the client is interested in. And the next step is to identify on our side who would be able to provide that knowledge. We always take a look about our own operation, who is the perfect counterpart to teach certain kind of topics, and is being able to either travel to a client, which is one example about how we do training, or if the client could come to our German operations and do a training actually in our operation itself. And then the next step is to detail the timeline of a training. If we're talking about a 2 or 3 week training, which is more superficial training, or maybe an intense training, which can be 2 or 3 months in some instances, and we identify what is actually required, and what timeline that can be done, and then to give the client a timeline and all the necessary steps, for example, all the preparations that is being needed for training. And then in the actual training itself, either at the client side or in our operations, we we always try to do a certain share of theory or theoretical training or class training and practical training, which is basically 50-50. Sometimes the focus is more on the practical aspect. And what's really important for us is that the training is sustainable. So we ask each trainee to do a daily diary, so a daily summary of all the topics that have been taught, to do a summary after a training, to summarize everything up. And we supply each client with a package of all material, all presentations, all summaries that have been done, so that a trainee or a certain department can look certain aspects up after each training. And what I think is also quite important for each client is that this involves a lot of networking. So also after training, we are always open to supply with knowledge, to get into contact with a specialist from the client side and to help with specific questions afterwards.
Perfect. Thank you very much for those insights, Andreas. All questions that have not been answered by now will be collected, and we will try to get in contact with you as soon as possible. Looking at the time, I would like to hand over to Tobias Metzger. Please go ahead, and thank you again, Andreas, for your insights and the presentation.
You're welcome.
Okay, Yannick, thank you very much, actually. Yeah, Tobias Metzger, my name, you heard me a couple of times already. Actually, I would like to thank all of you, yeah, from all over Latin America that participated here. Thank you for your time in this, in some countries, still early morning. And naturally, also, thank you very much for the AHKs, the cooperation there in the organization across these very huge continents. Work very well, and naturally also thanks a lot to my team and also to Henning and Andreas that gave, I'm convinced, that gave a good overview. And I can't say detailed overview because the time is too limited, but they gave, hopefully, and I'm convinced so, a very good overview of the topics. And I did realize by the questions that actually both in the hydrogen and also in the mining business, there is an interest in Latin America, and also what I learned myself from the activities that we have in Latin America. There is also the need, and there is the interest, and there is the need to move on, to move forward, to decarbonize both the electricity sector in general, but also the mining business. Yeah, and as Yannick already said, yeah, the questions that due to the limited time could not be answered, we are very happy to receive them from the AHKs. Usually this works very well, and I'm also sure this will work now, and we will answer them in the next couple of days. Also, if you have any further questions which may come up after a while, during the day or even during tomorrow or next week, please do not hesitate to contact us either directly. I think you have our contact data provided, or always the AHK in your country. And also, last but not least, for your information, I personally will be in Brazil in 2 weeks or 10 days from now. I will be at the Exposibram in Belo Horizonte, one of the big mining, or actually the big mining trade fair in Brazil. So for the Brazilians listening, or also from the other Latin American countries that may visit there, there is the chance to meet me in person there. Yeah, so thank you very much again. I wish all of you a great day, and I think Philip Bartsch is now saying some final words. Please.
Exactly. Thank you so much, Tobias. Yeah, also we think it was two very interesting hours. I think we could have made it easily 5 hours and then could have maybe even gone into more detail, to be honest. But yeah, for now, we think it was a great overview. I learned lots of things, and obviously I hope that you also enjoyed it, all of the participants. I need to say that it was the first time that we were able to organize a regional webinar with RWE and so many other in all the countries from Latin America almost. I hope it's not to be the last one. I hope you also liked it. You will receive a survey, as I said in the beginning, where you can just tell us your experience, give us feedback. We're really looking forward to this. And yeah, your feedback is appreciated, because we don't want to just do webinars to do webinars. It should also have a practical implication for you. So this is really important to us. For us, the German Chamber of Commerce in Chile, but also for Mexico, Brazil, Uruguay, Colombia, Peru, we thank you very much for the participation. We thank all the speakers. I think, it was really great. Lots of information. We hope that you as participants can take something with you to your companies, to your businesses. We thank you all for the 2 very interesting hours, and wish you very good greetings from Chile and from all the other countries. Thank you so much.